So this was a pop quiz I shared yesterday with all of you, which was related to general thermal and waves topic. Velocity is a vector quantity. You can also annotate on the screen. You can also use a chat to answer this. So velocity is a vector quantity, but speed is a scalar quantity. How vector quantity differ from the scalar? What is the difference between scalar and vector? How scalar and vector quantities are different from each other? You can annotate on the screen. You can use chat. You can use mic. You can also use a chat to answer. Yeah, that's right. So velocity, how vector quantity differ from the scalar quantity? So vector quantities have magnitude and direction. So vector quantities have both magnitude and direction, where scalar have magnitude but no direction. You can annotate on the screen to circle, underline all the vector quantities in the list. What are the vector quantities in this list? We have different vector quantities. What are the all the vector quantities you have to list? So acceleration and momentum. The distance is a scalar, energy is a scalar, mass is scalar, temperature is also scalar. Look, this question is of 1 mark. For example, if student underline acceleration, momentum, and example temperature, so you will lose the mark because you have to select only the vector quantity. So if any scalar you selected in your option, you will, because in IGCSE no half marks, either you score or there is a 0. Figure 1.1 shows a passenger running across the large ship at a right angle to the direction in which the ship is moving, due east, and a north is given to us. The passenger run across the ship at a speed of 2.4 meter per second due north, as you can see here, and the large ship is traveling due east at a speed of 6.8. Determine either graphically or by calculation the resultant velocity of the passenger. If they say graphically, like we have to scale, select a scale and then do measurement. And then we need the direction or angle from the north. So first, how to draw this figure? Whenever you see a question related to the vector, resultant of the vector, first you should draw a vector diagram. And because you will have only perpendicular vectors or right angle vectors, so first sketch the right angle triangle. Any one of them you can draw first. Like example, if this is east, so example, we are drawing east, the direction. So this will be east, which is 6.8 meter per second. Then the second vector will start from the first vector. Like we draw the first vector, and then from the head of the first vector, we'll draw the second vector, which is north 2.4 is there. As you can see, 2.4 north meter per second. What will the resultant? Resultant is always from tail of the first to the head of the last. So this will be your resultant. And it will not make difference to the magnitude of the resultant. If, for example, if you consider 2.4 as your first vector, so first you will draw 2.4. So first we'll draw 2.4 here, meter per second. Then we will draw 6.8. So then we'll draw 6.8 meter per second. What will be our resultant? Our resultant, this will be our resultant from tail of the first to the head of the last. And the second point they ask, dash degrees from north. So we have to measure the resultant angle of a resultant from north, or theta is here. So with reference to theta, what are the side? Look, first, if we need the height, this one is, because the angle is always between the base and the hypotenuse. So this one is a hypotenuse opposite to the 90. So this one is hypotenuse. So the other, this side will be base, because the angle is always with the base angle is between the base and hypotenuse. So if one side of angle is hypotenuse, the other side will be base, and opposite to the angle will be perpendicular. So these are the side we have: base, hypotenuse, and perpendicular. So first we'll use a Pythagoras theorem in which the hypotenuse square is equals to base square plus perpendicular square. So we'll take a root. What is a base for us? It will be 2.4 square. And what about the perpendicular, which is 6.8 and also square? So what's the answer for this? The hypotenuse? 2.4 square plus 6.8 square in a root. Two 2.4 plus 6.8 in a root. What's the answer for this? When you take a root, under root, the sum of 2.4 square plus 6.8 square in a root. 7.2. So this will be 7.2 meter per second. Then we need the angle. How to work out the angle? You can use a trigonometric ratio. Now we have all the size, like we have, this is 7.2 meter per second. This is 6.8 and this is 2.4. You have all the sides. So any trigonometric function you can use. You can use tangent theta. You can use cosine theta or sine theta. So tangent theta is perpendicular divided by base. So tangent theta, what about the perpendicular? The perpendicular is 6.8. And what about the base? It is 2.4. If we need theta, it will be tan inverse 6.8 divided by 2.4. So tan inverse 6.8 divided by 2.4. What will be the angle? You can use the chat to state. 70.6. So this angle we get 70.6. 70.6 or 71 you can say. 70.6 or 71 degrees, and the value. Okay. So 71 is there. So 71 we will write, rounded off value. And what about the velocity? The magnitude of the velocity, it was 7.2. When you're measuring the angle, then it should be a whole number. But when you're in a calculation, you can write your angles as a number. Like you can write 70.5. But it's better you convert the angle into a whole number. So it's a right thing when you're writing an angle, better to convert into a whole number. Yeah, that I mentioned. Is it clear, this question? In question 2, a spacecraft of a mass 300 kg moving in a straight line at a speed of 800 meter per second. What is the momentum? You can use my chat or screen annotation to answer these questions. So how to work out the momentum? We have the mass, and I want the active participation as it's a part of the preparation. So momentum, it can be denoted by P is equals to mv. So whenever you're solving a question, always write the formula first, and then it will be 8. So 300 multiplied by 8,000. So 8 multiplied by 3 makes 24. And then we'll have 5 zeros. Because it is 300 multiplied by 8,000. The next is the fuel on the spacecraft explode and the spacecraft split into two parts. The direction in which the parts move does not change. After the explosion, the speed of the front part increases to 9,000 meter per second, and it has a mass of 150 kg. Calculate the speed of the rear part. Look, whenever explosion happen, we always use the conservation of the momentum, like the total momentum before should be equals to total momentum after. Like momentum should be conserved. So what was the initial momentum? Same, it should be the final momentum. So how we can work out? The spacecraft was moving initially, as you can see, because it's a continuation of the topic, continuation of the question. First, a spacecraft of mass 300, it was moving in a straight line. So this is spacecraft example, which has a mass of 8,000 and mass of 3,300 and moving at a speed of 8,000 meter per second. Then what happened is this spacecraft exploded. It exploded into two parts, the front and the rear. The front part, which has a mass of 150, so this has a mass of 150 kg. It moves like its speed increases to 9,000. So for this one, like speed has changed to 9,000. For this rear part, first, what will be the mass of the rear part? The mass of the rear part will also be 1, because the total mass was 300. If the front part was having a mass of 150, the rear part will also have a mass of 150. But it move at a speed x, which we don't know. And it will move in opposite direction. So if this we consider as a positive velocity, so this will be the negative velocity. Now we'll use a conservation of the momentum. What is the conservation of momentum? We have the formula m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. What was the starting momentum? Because starting this spacecraft was moving, it was not stationary. So you cannot say that the initial momentum is zero. The total initial momentum, which is m1 u1 plus m2 u2, it was, because 300 multiplied by 8,000, so it will be 2.4 million will be the initial. So this whole is 2.4 exponent 6, you can also say. M1 is the mass of the, for example, the front part, and the speed at which it moves, it is 9,000. M2 is the mass of the second part, but the speed at which it is minus x. Why we are taking minus x? Because it moves in opposite direction. If it move in the same direction, so we'll take as plus x. But because it has moved in opposite direction, so we have to take as minus x. Then we just have to simplify this equation. So 150 into 9,000. This will be added, other side will be subtracted. So 150 multiplied by 9,000. So it will be 1.135. So 1.35 exponent 6, I can write in exponent because it's a large number. So 1.35 into 10 to the power 6. This is minus, because plus minus 150x. And this was 2.4 into 10 to the power 6. We'll solve here. Like 2.4 will move this side and 150 opposite side. So this is negative 150x. Other side will be plus 150x. And this will be, this is 1.35 into 10 to the power 6 minus 2.4 into 10 to the power 6. Or you can move the other side. You will get a negative answer, shows like it is moving in opposite direction. So after subtracting, So it will be 1.35 into 10 to the power 6 minus 2.4 into 10 to the power 6 divided by 150, and this will give us the value for x, the magnitude, which is about 7,000 meter per second. Is it clear, this one? How we worked out the speed of the rear part? Anyone having a doubt or a question till this point? If your answer, yes, 7,000, yes, rounded off, I wrote the rounded off answer, 7,333, that's fine, 7,333, that will be exact value. I just rounded off the final answer, but it's fine, 7,300. But what if the same question was there and initially the rocket was stationary? The example, the same rocket propulsion question, and initially the rocket was stationary. So in that case, like we use a formula m1u1 plus m2u2 is equals to m1v1 plus m2v2. In that case, the initial momentum will take as 0. But because this is a moving rocket, that's why the initial momentum was not 0. So keep one thing in mind, like check initially whether it was stationary or it is moving. The total kinetic energy of the two parts after explosion is greater than the original. State the energy transfer that occur in this explosion. Like initial kinetic energy was less, but the total kinetic energy after the explosion is greater than the original energy of the spacecraft. What is the reason for that? Because what actually happened, the fuel, it's having like a chemical energy, so the chemical energy has converted into the kinetic energy. Like because it exploded, so the fuel burned. The explosion will change the chemical energy to kinetic energy. That's why initial energy was only kinetic, but later it get energy from the stored chemical one. The explosion lasts for 0.2 seconds, the average force on the front part. So if we need the average force, we have the formula impulse is force multiplied by time. So if we need the force, force is impulse divided by time. We have the time, but what about the impulse? For the front part, like what is the change in momentum for the front part? If we consider, like initially this was moving at a speed of 800. Say this is representing example a rocket which was having a front part of mass 150 and the rear part also mass 150. It was moving, the whole rocket was moving at a speed of, we can use a formula F is equals to ma. You will get the same result. So this is 8,000 meter per second. But later when it exploded, the front part move at a speed of 9,000 meter per second and the rear part move at a speed of 7,000 or 7,333 meter per second. In the question, we just need the force on the front part. So if you need the force, you can work out the acceleration and F is, you can use a formula F is equals to ma, you will get the same answer. Or if you use that force is impulse divided by time, it won't make difference. So impulse is a change in momentum, which is mv minus mu divided by t. M is the mass of the part, which is 150. So 150 multiplied by the speed. The speed is 9,000 minus the mass is 150 and the speed is, initial speed is 8,000 and divided by the time interval 0.2. This will give us the force. Or if you use the formula F is equals to ma, so if you work out the acceleration, it's a change in velocity, so it will be 9,000 minus 8,000 divided by time interval, which is 0.2. This will give you the acceleration, and acceleration multiplied by mass, which is 150. So you will get the same answer. Actually, it's the same formula, but just modified for the impulse. So these two will give the same answer for the force. What's the answer for the force? $7.5 exponent 5. Okay. So answer for the force is, so even if this will be 7.5 into 10 to the power 5 newtons, this will also give the same answer, 7.5 into 10 to the power 5 newton. So you can use any formula. It can be related to the impulse in time, or it can be force, mass, and acceleration. Question 3, a plain irregular lamina of mass m, of mass 50 grams. It hangs from a nail that passes through a small hole at H. So H is a pivot for us. H is a point of rotation. The nail acts as a pivot, which they mentioned. The lamina can swing about. A lamina is held in the position shown in figure 3.1, a small distance above the horizontal bench. The center of the gravity of a lamina is G, means the weight is acting at this point. The weight of a lamina is a force that acts downward. Explain why the lamina experience a downward force. So why there is a downward force on the lamina? That downward force, because like that is a force of gravity, or that downward force, experience a downward force, that is because of the gravitational force of the earth. The gravity pulls, that's right. The pull of the gravity, it experiences a pull of the gravity or gravitational pull. That's why it will experience a downward force. Calculate the weight of a lamina on earth. So we have the formula, weight is mass multiplied by gravity. But in the question, the mass is given in gram. So you're not supposed to substitute in gram. You have to substitute in kilogram, kg. So mass is 50 gram. We have to divide by 1000 to convert into kg, and then multiplied by the acceleration due to gravity, or the gravity, which is 9.8. So 15 divided by 1000 into 9.8. What's the weight of this lamina? In newtons, 0.49 newtons. So if the mass is given in gram or milligram, you have to convert into kg. The weight produce a moment about the pivot through H. Use the figure, calculate the moment of the weight. So the weight is acting at this point, because the gravitational force is there. So weight is acting, and how much is the weight? That is 0.49. We want to calculate a turning effect. So if we want to calculate a turning effect or a moment, what we do to calculate a moment, we take a force and we take a distance, but both should be perpendicular from the pivot. So if we extend this line of the weight, if I extend this line of the weight, and then I extend the line for the distance, so means this distance I should take, which is 8 centimeter, or in terms of meter, it will be 0.08 meter. Because whenever we calculate a turning effect, it is a force multiplied by perpendicular distance, the 90-degree distance. So force is 0.49 and the perpendicular distance is 0.08. So the moment will be 0.49 times 0.08. That will be Newton meters. So 0.49 into 0.08, that is 0.039 Newton meters. The next part, the lamina is now released. The lamina is now released as shown in a figure 3.1. Describe what happened to a lamina from a time it released until it stopped moving. Look, just imagine if you're holding a cardboard or any irregular object from one end. You're holding from this point and you release. So what you will observe? You will observe that this will vibrate to and fro and eventually it will stop at this position. Where, because, so what actually happened? Why it is causing an oscillation? Say this is a lamina and here is the center of the gravity. So which is the responsible for the weight, and because this time the weight is acting downward and it is acting at a certain distance from the pivot, so this weight will cause a clockwise rotation. Because of the clockwise rotation, the lamina will rotate clockwise. Then what will happen? Because of its inertia, it won't stop. It will move to other side. Like it, as it is vibrating, this will be the new position of the lamina. Now center of gravity at this point. So weight is acting, again weight is acting downward, but this time the weight is on the opposite side of the pivot. What will happen? It will cause a rotation or a turning effect in opposite direction or anti-clockwise direction. And eventually what will happen? When the center of the gravity or the weight, the point where weight is acting, and the pivot, they are in line, there is no perpendicular distance. So in that case, it will stop oscillation. So continuously the weight is acting downward, which cause one end it cause a clockwise rotation and other end it cause an anti-clockwise rotation. And eventually what will happen? When the center of the gravity is just below the point of like the pivot, there is no turning effect because there is no perpendicular distance from the pivot. Is it clear? Anyone having a doubt or a question till this point? So the key points which you have to refer, like when lamina is on this, when we release the lamina, the weight will cause a clockwise, 3 marks are there. So when we release the lamina, the weight will cause a clockwise rotation. Then it moves to other side. Then the weight will cause anti-clockwise rotation. And eventually it will stop when the center of the gravity is below the center of the mass, or center of a gravity is below the pivot. So no perpendicular distance. To cause rotation. As there is no perpendicular distance, it won't rotate at all. Then question 4, figure 4.1 shows a long vertical tube which is sealed at the base and open at the top. The tube is 1 meter long. The cross-sectional area is 4 exponent minus 4 meters square, and it is filled with a liquid with a density of 1.4 exponent 4 kilogram per meter cube. Calculate the total pressure in the liquid at the bottom. So how to work out the pressure exerted by the liquid? So pressure exerted by the liquid is density into gravity into depth. And the atmospheric pressure is given 1 exponent 5. So what will be the, because it is open from the top. So as it is open from the top, the liquid will apply pressure. The liquid pressure, the pressure of a liquid will be equals to density, gravity, and depth. And if the question was calculate the pressure due to liquid, then we directly use this formula, density, gravity, and depth. But because they ask for the total pressure, then we have to add the atmospheric pressure. So atmospheric pressure plus liquid pressure equals to the total pressure. So pressure of the liquid plus the pressure of atmosphere, that will be the total pressure. So pressure of a liquid is density, gravity, and depth, and pressure of atmosphere is already given to us. which is 1 into 10 to the power 5 Pascal. So density, it's given in the question 1.4 exponent 4. So 1.4 into 10 to the power 4. The gravity is 9.8. The depth is 1 meter plus it will be 1 into 10 to the power 5. So this will give us the total pressure. So read the question properly. Like in exam, if it is pressure due to liquid only, then you will use density, gravity, and depth. But as they ask for the total pressure, then you have to use the atmospheric pressure as it is open from the top. So it will be 2.4 exponent 5 Pascal. If the height or a depth is given in centimeter, you have to convert into meter. Then we need the force exerted. So we have the cross-sectional area. Pressure is force over area. So if we need the force, force is pressure times area. So we have this value 2.4 into 10 to the power 5 multiplied by the cross-sectional area. It's given already in meter square. If it was not in meter, you have to convert into meter, because sometimes they give you in centimeter square. So if you want to have centimeter square, you want to convert into meter. Centimeter to meter, we divide it by 100. But because it is centimeter square to meter square, so divided by 100 square. Same thing, millimeter into meter, we divide it by 1000. But millimeter square to meter square, we divided by 1000 square. So if the unit was not in meter square, then you have to convert into meter square. So when we multiply them, we'll get how much force it will experience. What's the answer for this? 2.4 exponent 5 multiplied by, so this will be 2.4 into 4 and then multiplied by 10 because 1 exponent. So 9.6, 90. No, you have to multiply them. 2.4 exponent 5 multiplied by 4 exponent minus 4. 4 exponent minus 4. And this was 2.4 exponent 5. So it will be 96 newtons. Even without calculator, you can do this. It is written 2.4 into 10 to the power 5 multiplied by 4 into 10 to the power minus 4. So these bases are same. 5 minus 4, it will be 1, 10 power 1. And 2.4 multiplied by 4, that is equals to 9.6. So 9.6 exponent 1 means 96 Newton. A small sheet of a glass placed in over the open end of a tube, and that is inverted into a container of a dense liquid. The open end of a tube is and the sheet are short distance as below the surface, as you can see. And then sheet of a glass is removed, like we remove. Describe what happened in inverted tube when the sheet of a glass is removed. Look, first thing, there are two pressures here. One is the atmospheric pressure of atmosphere from outside. One is pressure from a liquid inside. So two pressures are there. One is the atmospheric pressure, one is a liquid pressure. When you check, look, the liquid pressure, as we already calculated the liquid pressure, it was higher initially. Even if you multiply like these numbers, 1.4, the density into gravity into depth, so you will get a higher value. So initially what will happen, initially when we remove this glass sheet, the pressure of the liquid in the inverted tube is more than the pressure of atmosphere. So as a result, what will happen? The liquid will move out. And eventually what will happen? It will stop. When it will stop? When the pressure of the atmosphere from outside is equals to the pressure of the liquid from inside. So initially when you invert this and remove this the glass sheet, the liquid will move out because the liquid pressure is more than the atmospheric, because atmospheric pressure try to push it inside, liquid pressure is causing outward motion. So initially the liquid pressure is more than the atmosphere, so the liquid will move out from the inverted tube. And then eventually what will happen, the liquid will stop at certain point when the pressure of the liquid is equals to pressure of atmosphere. So the points you should mention here initially, when we remove this slide, the liquid pressure is more than atmospheric pressure, that is 1 point. So the liquid will move out, that is the second point. And the third point or a third mark, that once the liquid pressure from in the tube equals to atmospheric pressure, as a result, what will happen? It will stop moving out, or it will stop at certain level. Is it clear, this question?